So today we're going to look at a few electric circuits demos. So I'm going to start right here with the old potato clock. So here you can see it's showing a time. It's not the correct time. And the reason for that is because I'm about to unplug it. So here you can see that hopefully you can see there are two wires that come out of here, positive and negative. And the red wire is hooked to this potato, black wire is hooked to that potato. And so these potatoes are forming the battery. And so we have to use two different types of metals here. So you see this green wire connecting them. So I can show you that it's working by unplugging it here. So I unplugged it, it turned off, and then I can plug it back in and turn it right back on. Because the power is coming from the potatoes. It's really the acid in the potatoes. Now, usually when we say that, and you talk about fruits or vegetables, everybody thinks it's like citric acid, which is a good acid. But potatoes don't have citric acid, they have phosphoric acid, and that's why they still work. So that's potato clock. So now we have this demo here, as it says on the screen, of the series and parallel circuit with the Handcraft generator. So don't worry about series and parallel right now. That's just a label for this thing. So what we have here is we have this circuit, and I can put it down here. I have this hand crank generator, and as I turn the crank, I can make it light up. Alright, and the faster I go, more light it makes. Now, if I close this gate here, I can make both of these light up. But it's actually a lot harder for me to make them light up because I'm having to push more electricity through both of the bulbs, and so it gives me more resistance. And then if I disconnect it, you'll notice that it's super easy for me to turn, but it's not connected, so it doesn't work, which is why it's super easy to turn. So here, this is just a quick little demo of the hand crank generator producing power through this little circuit. Alright, so let's advance slides here to the next demo. So here it talks about the AC/DC demo. And so for that I have this little power supply. And you should be able to see that on the power supply I have a DC side and an AC side. I'm not going to use the AC side, I'm just going to plug it into the outlet when I need AC, because the outlet provides AC. So here, we're looking at DC versus AC. So DC is direct current. That means it only goes in one direction. So for this thing here, when I turn it on, the current will come out of the red end, go through whatever circuit I have, and then come back through the black. Like it just goes to one direction. Okay, so it's DC direct current. So to demo that, I have this wire here. So I've got 3 prongs on this wire, and at the end of it I have this LED. It's actually 2 LEDs. We'll talk more about that in a second. So here you got 3 prongs, and so remember this round prong is the ground. I'm not doing anything dangerous, so I don't really need the ground. And so I'm going to put the power in here. So I'm going to do this so that I'm going to put the red one on the my left side, L's right, and the black one is right there. So I'm going to start like this, okay? So when I do that, I'm going to turn this thing on, and so I've got it up at about 25 volts, 0 amps. Now when I do that, you'll notice that the LED turns a little orange. So let me turn off the light here, so you see this LED a bit better. So here, I've got orange LED, and so as I mentioned, this looks like just one LED, but there's actually 2. And so this one, when I have the red on the left-hand side here, lights up orange, and you should be able to see that that's a solid orange. Right? And I'm shaking it because it makes it obvious if it's turning on or off. Okay, this is solid on, right? There's no question about that. So now what I'm going to do is I'm going to switch this. So I want to make sure y'all can see this. Turn the lights back on. So here, this is solid orange, it's still on, so now I'm just going to switch it, okay? So I'm going to change from black being on the left to black being on the right. Connect my red here. Fall off, there we go. And so now you should be able to see that that's green. That should be pretty solidly on green. Turn the lights back off. And that is a solid green right there. Okay? And as I shake it, there's no change. Okay? So now, so originally we had like the current coming in on my left-hand side, going through the circuit, come back on the right. Now this time the red current's coming in on the left-hand side and coming back out on the right. And so we have two LEDs here, but they'll only light up depending on the direction that the current is going. So now let's look at AC. So I'm just going to plug this right here into the outlet. And when I hold it real steady, it looks like, which one's on? Well, they kind of both look on. Because they are both on. So if I hold it here, I might be able to see that. There's actually two LEDs and they look both on. Now they're not constantly on, okay? Because the AC that comes out of the wall here, it's 120 volts, which hopefully you know. But in this country, we decided to do it at 60 hertz, or 60 times per second. What that means is that every second, the current's going to be going, say, in through the left prong. It will go in for a fraction of a second, stop, turn around, and come back, and go out through the left prong. So it's just alternating back and forth, back and forth, back and forth. And it's doing this 60 times per second, okay? And because of that, if you're looking at this LED as I hold it, it looks like it's stationary, like they're just on the whole time, but they're not. And the reason why it looks like they're on the whole time is I mentioned it's at 60 hertz. Well, the human eye can only make out about 24 hertz. And so each one's turning on and off about 30 times per second, which is faster than we can perceive. But again, if I shake it, you should be able to see that it's on and off pretty fast, okay? And with this shaking back and forth here, you should be able to see a couple of things. You should see that it's like green and then orange and then green and then orange in a pretty consistent pattern. But more than that, you should also be able to see the black spaces between each color. So remember that it's going, say in through the left side, but then it has to stop in order to turn around. Just like when you throw a ball up in the air, it has to stop, turn around and go back. And then when it goes back, it has to stop, turn around and come forward. So as it's doing that, every stop is off, okay? So this demonstrates that the current is going back and forth, it's alternating. Whereas when I did this with the DC, you saw no alternation, right? And so again, when I hold it, it looks pretty stationary, but it's not. It's alternating back and forth. And that's the end of our demos, so hopefully y'all learned something.